It's nice to be with you again. Our topic for this meeting is on alcohol, ethers, and epoxide. So this is a new group of organic compound that we are going to focus on. Alcohols has a symbol of ROH, that is your alkyl group, and the functional group that defines alcohol is OH. Another group that is similar to alcohol are the ether. However, the ether has the formula ROR. The main difference to that of alcohol is alcohol has the OH group, whereas for ether, you have the OR group. Now, in terms of aromatic compound equivalent, we have the epoxide. So, you have here the oxygen enclosed with carbon. So CCOC. We have also another example of an aromatic compound that is phenol. However, the phenol, aside from having the benzene ring, it also possesses the OH group. So in this session, we're going to focus on alcohol, ethers, and epoxides. This is your alcohol and its structure and bonding. It has 4 free electrons, and to one side is the hydrogen, and bonded to the other side is an alkyl group. It could be an aliphatic compound or group or alkyl group, or it could be an aromatic alkyl group, or even a halogen or other compounds or alkyl. So in this manner, if we're going to change the R into a benzene ring, it is called phenol. Now, if we're going to change the H with R, it is ether. If the oxygen is enclosed, it is epoxide. Okay, what are alcohols as defined in chemistry? Alcohols are molecules containing the hydroxy functional group, the OH, this one, that is bonded to the carbon of an alkyl or substituted alkyl. So the OH here or the hydroxyl here serves as an alkyl group or substituted alkyl group. The hydroxy functional group strongly contributes to the property of alcohol. So what makes alcohol an alcohol is the presence of the OH linked to a big molecule of hydrocarbons or a carbon containing compound. Now take a closer look of the structure OH. The presence of the structure OH make alcohol polar or hydrophilic or making alcohol soluble in water. However, the solubility of alcohol is not the same with all the other kinds of alcohol. There are some alcohol that are infinitely soluble with water. However, there are also alcohol that are near to insoluble to water, and there are also some alcohol that are insoluble in water. The shorter the attached alkyl group, this one, the shorter this is, the polarity is greater, hence it makes it more soluble in water. So as you go down the alkyl series, attached to the OH functional group, it becomes more insoluble with water. Okay, these are hydroxyl groups in natural compounds. We have here cholesterol, and the OH is here. I think you know cholesterol. This is what you usually hear as something that is, if if its presence is in great excess, it could lead to high blood pressure. So this is the formula of the cholesterol present in your fats with the OH, the hydroxyl containing group. And then you have here cholecalciferol. This is the vitamin D3. It regulates the calcium level, or it helps in the maintenance of strong bones. So this is the R group, and there is the functional OH group. And then we have also here a very uh, expensive compound that is prepared in the lab, and it is usually used in making perfumes or scent for your soap, even lotion, the geraniol. The geraniol smells like roses, so the scent is sweet. So the alcohol is not just simply the alcohol that we are using these days to fight against your COVID virus, but you can see alcohol in the blood, cholesterol in the blood, cholecalciferol for the maintenance of healthy bones, and also likewise for commercial purposes like making perfumes or other scents needed for other toiletries. And then we have also aromatic alcohols or the phenols. This is, I have introduced to you the phenol, and then this is the dopamine. Usually you can hear the dopamine as something that increases your attraction or your uh, movement towards a certain thing. The dopamine is a neurotransmitter that is deficient in Parkinson's disease. So if you see a person with Parkinson's disease, one of the symptoms is the involuntary movement of any part of the extremities, especially the fingers or the hands, or even some parts of the face. So the absence of dopamine leads to the presence of the disease Parkinson's. And then you have also the uracils. This is dangerous. The uracils are present in leaves of poison ivy, and it could cause skin irritation. Um, of course, you are not familiar with poison ivy or the ivy plant itself, but this is actually a vine, and the gatherers of poison ivy usually encounter skin irritation. And what is the irritant is a phenol uracil, and this is how it looks like. So you have there the functional group, and the whole of this is the alkyl group. And then you have here the capsaicin. The capsaicin makes your chili pepper spicy or other spicy ingredients that is hot in nature is the capsaicin. So this is your alkyl group, the black one. And of course, the red one is your phenol. And then you have also the THC. If you notice, the formula is looks like a crawling insect or a crawling man. It is sorry, called the tetrahydrocannabinol. It is a psychoactive drug found in marijuana. In fact, marijuana is also known as cannabis, and also its scientific name contains the word cannabis. And the active molecule in marijuana that could lead to hallucination is tetrahydrocannabinol. Okay, let us try to look into the hybridization of the carbon directly attached to the functional group of alcohol. So you can see there on your screen that this is the main carbon attached to the hydroxyl group. So it carries the sp3 hybridized carbon. Now, because of that, the carbons are classified into primary carbon here, tertiary carbon, or the secondary carbon. The primary carbon contains only one alkyl group. Secondary carbon contains two alkyl groups. Tertiary carbon contains three alkyl groups. So primary is to 1, secondary is to 2, tertiary is to 3. So this is the sp2 hybridized carbon, now in the single bond carbon, double bond carbon. So this is the enol portion of the phenol. In aromatic compounds, the carbon has the hybridization of sp2. So this what makes different from the aliphatic alcohols or alcohols. So if you have seen the enol group, the double bond COH functional group, the carbon there is hybridized as sp2. For single bond, sp3. And then you have also ether. The ether contains two alkyl groups. And then we have symmetrical ether. The symmetrical ether has the same alkyl group. Whereas for unsymmetrical, the alkyl group could be different. Okay, this is the epoxide. Epoxide is a special type of ether that is claimed by some books. Although epoxide could be classified as one group. So epoxides are ethers having the oxygen as part of a three-membered ring. Sometimes your epoxide is also called or referred as oxyrings or the alkene oxides. So if we're going to look at uh, the oxygen or the alcohol OH group could have the sp3 hybridization for the single carbon oxygen bonds, whereas if there exists a double bond, it holds the sp3 hybridization. Okay, look at this concept. The bond angle around oxygen atom in alcohol or ether is similar to the tetrahedral angle of 109. If you can remember, the 109 bond angle is similar to that of water. Now let us go to nomenclature. Nomenclature is just as the same as that of the principles used in alkene, alkyne, and alkanes. So what you have to look at is to look for the longest carbon chain in which OH is attached. It is not necessarily a part of the longest carbon chain, but it is the longest chain wherein an OH is attached. So in this case, you have 1, 2, 3, 4, 5, 6 carbon. And if you're going to look at, there is an OH that is attached there. Okay, so the first thing that you're going to write is the OL, implying that this is alcohol. And then you write the prefix for the longest carbon chain. Since it has 6 carbon, it is hexane. Remove the E and change with suffix OL. So it is hexanol. Again, you check for the presence of alkyl group. So you could have here one alkyl group, the methyl group. Now, after determining the longest carbon chain, the next is you have to number. And numbering is starting from the carbon that is nearest to the functional group OH. So in this case, the numbering of carbon is 1, 2, 3. If we're going to start here, 1, 2, 3, 4, that is wrong. So the numbering is 1, 2, 3. So the OH group is found in the third carbon. So you can write there 3-hexanol here, 3-hexanol, meaning to say the OH is in the third carbon of the longest carbon chain. And then the alkyl group methyl is found in carbon 5. So you write methyl and then towards the left you write 5. So the name here is 5-methyl 3-hexanol. I repeat, this is an alcohol, you write OL. It has 6 carbon, you write hexanol, that's the ol. In numbering the carbon, the hexanol or the OH group is found in the third carbon, so 3-hexanol. There is an alkyl group and the alkyl group is methyl, you write methyl, and methyl is found in the fifth carbon, so the answer is 5-methyl 3-hexanol. So maybe you can realize now that if you have not understood or will not practice on naming your hydrocarbons, you could hardly go with the naming of alcohols. But since I think you are ready with your naming of hydrocarbons, it is now easy for you to name or give the IUPAC name of your alcohol. More practice or more illustration. There are some instances that the position of where the methyl ring or the alkyl group is present is being identified. So if it has only one methyl ring, it is called primary methyl. If it has two, secondary, just as the same. So I repeat, and to give more emphasis between phenol and alcohol, Alcohol and phenol contains OH, however, alcohol contains the sp3 hybridization. As compared with the phenol, it uses the sp2 hybridization. Both are important solvents and synthesis intermediates. They are polar, so alcohol is miscible with water. Phenols contains OH group connected to carbon in a benzene ring. So the naming of alcohol in terms of carbon also follows the aliphatic way of naming. Methanol, ethanol, so propanol, butanol, it follows the carbon series. Okay, these are common name of aromatic compounds as illustrated based on phenol. This is your methyl salicylate. The main difference with the phenol is the presence of CO2 CH3. And then you have also aerosols. The aerosols contains two OH group. And there are different types of aerosols depending on the kind of alkyl group. Usually up to 15 carbons only. Okay. Some more illustrations on IUPAC naming. So in this case, you can already see there the number. It is 5. So it is, you write all, penta. The OH is found in the second carbon. So you write there 2-pentanol. There is an alkyl group, the methyl, and is also found in the second carbon. So the name is 2-methyl 2-propanol. Now, how about for aromatic compounds? Okay. In case there are two OH, like your urosols, you write there diol, meaning there are two OH group. So it is an aromatic compound. It has 1, 2, 3, 4, 5, 6, 7, 8 carbons. So it is hexane aromatic cyclo. Now that is cyclohexanediol. Next, since there are two OHs, you have to know where are these OHs. So you have there to start one with the OH. So 1, 2, 3, 4. So you have 1, 4 cyclohexanediol. Now, if you want to write further the characteristics or to the name, you can have this as uh, the cis or the EC, the cis and trans. Since both of these belong to the same plane, they are called cis-1,4-cyclohexanediol. But it is already enough to write 1,4-cyclohexanediol. And then this is one thing that is confusing. Now, if you're going to look at, you have here 1, 2, 3, 4, 5, 6, 7, 8. That is a phenyl ring. Okay. But why is it that you have to count here the 1, 2, 3, 4? Again, I repeat. The first rule is to look for the longest carbon chain that OH is attached with. In this 8 containing carbon, it does not contain any OH. But in this aliphatic structure, it contains the OH. So, this is 1, 2, 3, 4. It is butane, butanol. So, the number of carbon, you have the 1, 2. You start numbering the carbon where the OH is. So, you have 1, 2. You have there 2 butanol. But you have an alkyl group, the phenyl ring. So, you have to continue 1, 2, 3. So you have 3 phenyl 2 butanol. Okay? There are also some instances whereby you have here a name phenyl methanol. But you can also commonly call this as benzyl alcohol. Okay? This is allyl alcohol, but in its IUPAC name, this is 2-propene-1-ol or true 2-propanol. Okay? So we have here also the tertiary butyl alcohol. So if you notice, the number of carbons attached to the carbon 1 are 3 alkyl group. But actually, this is 1, 2, 3, 4. So it is butyl alcohol. It is tertiary because you have the 3 carbons attached to the main carbon. Okay? And then, of course, the scientific name is this is 1, 2, but there is a longer chain here, 1, 2, 3. So you have propanol. And the second carbon is attached with the OH. Now, since this is the parent chain, then this carbon here is an alkyl group. So this alkyl group is again found in the second carbon, so the name 2-methyl 2-propanol. Okay, in this case, there are 2 carbons, so ethane, ethaneol. But since there are 2 OH, it is ethanediol. And the ethanediol, the OH group are found in carbon 1 and in carbon 2. So 1,2 ethanediol. How about in this case? The longest carbon chain is 3, so it is propanol. But since there are 3 OH group, it is called propanetriol or propanetriol, and the carbon is found in, or the oil is found in carbon 1, 2, and 3. So this one is 1, 2, 3 propanetriol. These are special instruction in naming of alcohol. Okay, this is an aromatic structure. You have there the OH. Of course, this serve as the carbon 1. So 1, 2, 3. Going towards the alkyl group. That is not going counterclockwise or clockwise, but it is going towards the nearest alkyl group. So this is hexanol, cyclohexanol, because it is in its aromatic structure. And then there is an attached alkyl group, the methyl, and it's found in carbon 3. So it is 3-methyl cyclohexanol. Okay, let us try to look at this example. You have, of course, still cyclohexanol, but here is your OH group, and the nearest alkyl group is this one. So you have 1, 2, 3, 4, 5. In carbon 5, you have 2 methyl. So you have methyl attached to carbon 5, another methyl attached to carbon 5. So another methyl attached to carbon 2, so it is trimethyl. And they are positioned in 2, 5, 5. Trimethyl cyclohexanol. There are some instances whereby uh, two the same alkyl methyl is present. This is your isopropyl alcohol, meaning to say there are two the same alkyl group present. So you have the prefix iso. But in this case, you have 3 carbons, so it is isopropyl alcohol. This is your rubbing alcohol. This is the alcohol that we are using now to protect ourselves from being visited with COVID virus. Okay. The diols are also referred to as glycol. So in this case, you have the ethylene 2, ethylene glycol. But the scientific name, the IUPAC name is this one. So you have also here glycerol. Okay, there are 2 carbons here, so ethyl ethane. So ethylene glycol. And then in this case, it is glycerol. So this is your glycol. So there are 1, 2, 3 in IUPAC name. There are 3 alcohols, so it is triol. There are 3 carbons, so propanetriol. And the OH are found in the 3 carbons, so you have 1, 2, 3. Again, a review for your aromatic. There are 1, 2, 3, 4, 5. There are 5. So this is pentane. But there are 2 OH because these are diols, so you have cyclopentanediol. And of course, the first carbon contains the OH, so you have 1, 2. So you have 1, 2 cyclopentanediol. Now, how about ethers? If the alcohol ends with ol, how about the ether? The word ether is one of the words in IUPAC naming of ether. And this is the last word. So in this example, the you have here one, this is the R, this is the O, and that is the R. I hope you can still recall your basic formula for ether. Here is the R, this is the O, and this is the R. So this is an example of symmetric ether. This is asymmetric ether. Okay, so you write ether and then you identify the R or the alkyl groups. Here you have methyl. In this case, you have 1, 2, 3, 4. So it is butyl. So, sorry, this is butyl methyl ether. By the way, you write the one with uh, first letter as they appear in your alphabet. B comes first before methyl or M. So you have the butyl, methyl, alcohol. And then you write secondary if the butyl is the second R. Okay? And then this is diethyl. Very easy. That is ethyl, diethyl ether. Okay, these are examples of alkyl group attached to aromatic group, methoxy, ethoxy, tertiary butoxy. And then this is an example of an epoxide. This is tetrahydrofuran or the THF. You can usually see this in your kitchen utensils now, the tetrahydrofuran. The black lining that you can see in some frying pans or in your mixing bowls. Okay, how do we name the epoxy? First, you write the attached other non-epoxy structure. So in this case, you have the epoxy, the triangle with the letter O. That is your epoxy. So if you're going to look at, this is the attached portion. And there is the carbon and carbon. So this is cyclohexane. Next, you write epoxy. 1,2 epoxy. And then here you have 1, 2, 3 for the first carbon. And then you are going to write now 1, 2 epoxy, the epoxy first. And then you write the other carbon. Here in this case, it has nothing but hydrogen. So you just simply write epoxy. But since this is a triangle, you have to write there 1, 2 epoxy. And then the 2-methyl propane. These are attached in carbon 2 because the one with nothing is just simply carbon. But you have here in carbon 2, 2-methyl. So you have 2-methyl propane. Where is the propane? You have 1, 2, 3. Sorry. It should pass through the oxygen. So you have there 1, 2, 3. So you have here your uh, epoxy. Both carbon contains an alkyl group. The other one is um, ethyl, and the other one is methyl. So what is the longest carbon chain attached to the enclosed carbon-oxygen-carbon bond? You have 1, 2, 3, 4, 5. So you have 2, 3 epoxy pentane. Okay. Why 2 and 3? You go to the nearest structure of the epoxide. This is carbon 1, carbon 2, carbon 3, of course 4, and 5 to make it pentane. Okay, there are some instances by which This structure is just simply called oxyring. And this is also another example of an oxyring. Next time we will discuss also the properties of the alcohol, epoxides, and ethers. So this is all for today. Thank you for bearing with us again. Bye.